Okay, this is Acids, Bases, and Salts, Lesson 3, and we're going to talk about the Arrhenius theory of acids and bases today, which is one of 3 theories that we will talk about. An Arrhenius acid is defined as a substance whose water, or aqueous solution, contains or yields hydronium ions, which are H3O plus ions, as the only positive ion in solution. An example of that is HCl. It dissociates into H plus and Cl minus. In H2SO4, it will eventually dissociate both H's and SO4 2 minus. So strong acids dissociate 100%. And again, this is an example of dissociation. Now, what you're not seeing here is as soon as this H and the Cl separate in water, this H hooks up with H2O to form H3O, which is the hydronium ion. And there are 6 strong acids. You don't have to memorize them at this level, but if you're taking the next level class, you will have to know them. So we have HI, HBr, HCl, H2SO4, HNO3, and HClO4. Those are the 6 strong acids. All of them dissociate 100%. Now there are some general rules for acid. We've already gone over that. All acids start with H as the positive ion that's written first in the chemical formula. There are some examples which deviate from that, which are your organic acids. So I'll put exception here. Organic acids end in COOH. We'll talk about that more when we get to that unit. Not all substances that contain hydrogen are acids. So here's some non-examples of acids. You've got H2O, starts with H, but it's certainly not an acid. Methane is CH4. It contains H, but it's not an acid. Glucose is C6H12O6. It also contains H, but it's not an acid. Hydrogen peroxide, stuff we use to clean our wounds, H2O2. And even NH3, which is ammonia, contains hydrogen, but it is not an acid. It is considered a weak base. If we were to look at strong acids, what happens to them in solution, this animation will show you that as soon as HX hits the water, it dissolves, and the H instantaneously reacts with the water to produce H3O. It's in the water, it starts to dissolve, and immediately the H combines with the water to make H3O. You can see that the H plus is there present instantaneously and then reacts with the water. So you can see here strong acids dissociate 100% in solution as compared to weak acids. Weak acids ionize probably less than 5%. So we call HA basically weak acids. It starts to dissolve. Only a couple of them actually produce H plus and then react with the water to produce H3O. In the description it says 9 molecules of HA produce only 2 hydronium and 2 anions, A minus, while the remaining 7 remain intact and are the major species in solution. So the weak acids do not really dissociate in water. Okay, back to our lesson. So let's recall what we just talked about, what happens when a hydrogen atom becomes an ion. So here, hydrogen loses an electron because hydrogen has one electron and one proton. And when it loses that electron, it has a positive charge. Thus, hydrogen ion is essentially a proton. When in water, this hydrogen ion is naturally attracted to the unshared electrons and the slight negative charge of the oxygen in the water. It is believed that the hydrogen ion cannot exist as an isolated particle, so what forms is called the hydronium ion, which is H3O+. And you can see here, here's the water molecule, and this is what was happening in that animation. The H+ is attracted to the negative side of the water molecule and forms the hydronium ion. According to the Arrhenius theory, the properties of acids are functions of these hydronium or hydrogen ions. So because of that, we really say that H+ equals H3O+. Let's talk about different types of Arrhenius acids. We have monoprotic acids, those acids that have one H and they ionize in one step. Acids that produce one H+ in solution. So an example of that is HCl. It produces H+ and Cl-. We also have diprotic acids, acids that produce two H's and they ionize in two steps, that produce two H+ in solution. So in the first step, my first H comes off and I have H+ and I have HSO4-. Notice it went from H2 to HS because here's the second H. Then in my second step, I start with the product, HSO4. I remove the last H and I'm left with SO4-. So now both H's have been removed. Remember, this is a strong acid, H2SO4, so most of the H when it ionizes or dissociates is coming from this first H. Very little of the HSO4 is actually going to dissociate. This is a weak acid, so this is going to have like a double arrow. It's going to go back and forth, back and forth. It's really not going to dissociate much. And then we have triprotic acids, acids with 3H+, and they ionize in 3 steps to produce 3H+ in solution. So we're going to remove the first H, and I'm going to get H2PO4-, and then I start with that H2PO4-, I remove another H, and I'm now down to HPO4-, and then I remove the last H, and then I'm left with PO4-. Let's talk briefly about bases. An Arrhenius base is defined as a substance whose water or aqueous solution contains or yields and produces OH- or hydroxide ions as the only negative ion when dissolved in water. Two examples would be like NaOH or KOH. General rule for bases, it's usually a group 1 or 2 metal. Group 1 or 2 metal plus OH. And it contains an OH at the end of the formula. One exception to that rule is NH3, which is ammonia, and it is classified as a weak base. So just like acids with more than one H, we have bases. So we have monohydroxy, which means a base with one OH, and the OH dissociates or ionizes in one step, so I'm left with K+ and OH-. A dihydroxy base is a base with 2 OH, and it also ionizes in a single step. So here the Ca2 plus, and I've got 2 OH minus. And both of the OH comes off in one step, which is different from the acids. In the acids, you're removing one H at a time. And in a trihydroxy base, we have 3 OH groups. So we can, here we would have Al3 plus and 3 OH minus. Now, just as acids, not all bases that have OH are considered a base. For example, alcohols and organic acids are not bases. So below I've given you a list of compounds that contain OH but do not dissociate to yield OH ions. So we can write water as HOH, and it contains OH, but it is not a base, it is neutral. Methanol is CH3OH. It contains OH, but it is not a base, it's considered an alcohol. And methanoic acid is CH3COOH. It also contains OH, but it is not a base. Anytime you have nonmetals with a COOH ending, it's considered an organic acid. Anytime you have nonmetals with an OH ending, it's considered an alcohol. And we'll learn more about that in the organic chemistry unit. As I said, bases usually contain a group 1 or group 2 metal plus the OH ending. Okay, that's it.